Hello everyone, this is Manik Pandya, along with my teammate Abhishek Pingle. Our team name is Gen Warriors, and we have developed AI Open Source Dependency Guardian as a project for the virtual hackathon held on 20th July, which was hosted by Google Cloud in collaboration with Open Data Science Conference. So, what's the problem that we are trying to address? Firstly, open source is definitely powerful, but unmonitored dependencies are a silent threat. The 2025 Open Source Security Risk Analysis report found that 86% of code bases contain known vulnerabilities, and 90% of them are outdated. Most developers don't have the time or tools to catch every outdated or risky package, and that's exactly the problem we are trying to solve. We built AI Open Source Dependency Guardian, a secure by design AI agent that analyzes your dependency files, detects risk, explains the impact in simple terms, and recommends safer alternatives. And we built it all in just 24 hours at the hackathon organized by Google Cloud in collaboration with ODSC. So what's the solution? Modern apps rely on dozens or even sometimes hundreds of open source packages, but keeping those dependencies secure isn't easy. Most tools flood you with raw CVEs or require security expertise just to understand the risk. That's where AI Open Source Dependency Guardian steps in. At its core is an AI agent powered by Google Gemini and built using secure by design principles. It reads your dependency file, whether it's a requirement.txt or package.json, and checks for known vulnerabilities using trusted sources like NVD and OSV. Then it translates those risks into clear business impacts so both developers and stakeholders understand what's at stake. No jargon, just clarity. Furthermore, it tells you exactly what to upgrade, why it matters, and gives you a patched file ready to go. And here's the best part. Once you apply the suggested fixes, you can rescan the file and see the reduced risk score for yourself, validating the effectiveness of our AI agent, from raw data to real decisions in seconds. So moving on to the architecture, here's a quick look at how our system works behind the scenes. The user interface built with Streamlit handles file uploads, displays the overall risk score, detailed dependency analysis, and lets users download a patch file. At the core of the system is our AI agent, structured into three modules. First, the planner parses the uploaded file and decides whether to use cached results or trigger a fresh scan. Next, the executor builds a structured JSON prompt and calls Google Gemini to perform vulnerability analysis. It retrieves CVSS scores, explains the risk in business terms, and suggests safe upgrade versions, even generating a patch file automatically. The memory module stores past scan results in a local database. It tracks timestamps, risk scores, and suggested fixes, and even calculates whether the new scan improves security. Behind the scenes, we use Gemini as our reasoning engine, along with local parsers to handle dependency files. We have also built in observability with debug logs, graceful error handling, and automatic cleanup, making the agent resilient and user-friendly. Okay, let's get going with the demonstration part. So the users can basically use this particular URL in order to access this particular scanner. So a few things to notice: you can upload either requirements.txt file or package.json file, and the limit has to be 200 MB, that is the file size. Another thing to note is to keep track of the risk improvement, you need to keep the same file name when re-uploading your patch file. So just keep that in mind. So for testing purposes, I have selected two uh, two files. First is the requirement.txt from Pygode, which is basically an intentionally vulnerable Django application used by security professionals in order to practice Python web security. So I'll be taking requirements.txt from this particular setup. So let me just download it. All right, so I do have my requirements.txt file. And for the package.json file, I will be using the package.json file from the OAS juice shop, which is again a vulnerable application which uses Node.js under the hood. So I'll just go ahead and download the package.json file for this as well. All right, so now we have the files. Let's start with the testing. All right, so I'll start with the requirements.txt file. And it basically takes some time to scan those dependency files because it makes API calls to the OSV database in order to identify if a package is vulnerable or not. And then the whole context goes to Gemini, which provides us with all sorts of analysis. So let's wait for some time. All right, so the analysis is complete. The risk score identified is 28%. And since this was our first scan, so here are some of the vulnerable packages. So here you see Certify has a high vulnerability and has a score of 7.5. If I click on this, it will basically navigate me or take me to the appropriate vulnerability. That is, Certify is a curated collection of root certificates for validating the trustworthiness of SSL certificates. And if I click on another vulnerability, this is also related to Certify. So yeah, we have several vulnerable packages. So this is how we get our patched versions. So I'll just go ahead and download the patch file. As I mentioned before, I need to rename this. So let me do that. All right, so let me just upload the patch file and let's see how does it perform. Yep, here it is. And this should basically work for us because we have included all the patch files as per the recommendations. Let's see how does it work out for us. As you see, the risk score dropped significantly and basically it eliminated every single vulnerability that we had. So all dependencies are secure, no actionable vulnerabilities found. And you can see all packages are already at a safe version. So yeah, this was regarding our requirements.txt. Now let us do the same thing with our package.json. Right, let's start. This file is a bit longer, so it might take a few more minutes. As you can see, there are a lot of dependencies as well as dev dependencies. All right, so every single so there are some seriously high risk vulnerabilities right here. So if I show you, there has been one with a 7.7 base vulnerability score for Express JWT. So if I click on this, it basically points me towards the same vulnerable package and it describes what the vulnerability is. So let us do one thing. So these are the patched versions for the same. So let me just download it. And again, I had to rename it again in order to have that consistency. And let me rename it. So now just rescan the patched file. And this time there should be a reduction in our risk score. All right, so as you can see, there is a significant reduction in the risk score. The risk score did drop to just 20 and it improved by 80 points since last year. All right, so as you can see, all packages are already at the safe versions. All right, so one important thing that I did want to point out is the patched file maintains your original structure. For example, if I show you the package.json, it is the updated package.json, and compare it with our original file, you can see here perfectly, right? And here I did show you that Express JWT was vulnerable. Here you can see it was 0.1.3. Here it got updated with a fix of 6.0.0. And if you see the whole structure is intact, this is something that you can just plug in and get going. So yeah, this was the demo for my AI Open Source Dependency Guardian. And thank you for watching. In just 24 hours, we built more than a prototype. We built a foundation for intelligent, secure open source development. AI Open Source Dependency Guardian doesn't just detect vulnerabilities, it explains them in business terms, recommends precise fixes, and proves its impact with measurable risk reduction. Next, we plan to add an interactive chat mode for follow-up questions, turning the tool into a true dependency advisor. We'll also introduce file versioning to track risk evolution over time, integrate live CVE feeds for real-time analysis, and build automated pull request generation for seamless integration into CI/CD pipelines. We are not just securing dependencies, we are redefining how developers build trust into their code. Thanks for watching. Link to the GitHub repo is in the description. We would love your feedback. Thank you so much.